All right, well, thank you for having me today. I'm really excited to be here. I do have to give you a disclaimer first. Apparently, Andy's been telling people to come see my show. Just in case there's any confusion, there is no singing and dancing. I am an engineer. I will, however, do my best to not bore you, if that's a fair trade-off. So, let's see if my slides come up. I do work for a hardware company, but I am a software person at heart. My background is in computer science, not electrical engineering. However, as I've worked with Intel, I've learned that I actually am a hardware person as well. And in my job, I get to see kind of the best of both worlds. So my job is to work with developers such as Aerospike and help them enable and optimize their software for Intel architecture or Intel hardware. And then I get to go back to Intel and give them kind of the voice of the developer. What are you looking for? What works well, what doesn't? So that brings me to why I'm here today. As you can see, I'm going to discuss Intel's persistent memory and how Aerospike has been working with us to enable this. Maybe. There we go. So I'll give you a quick overview of the actual technology behind Intel persistent memory. I'm sure you've heard the term Intel 3D XPoint technology, so I'll make sure that we have, clear up a little bit of the confusion between the two terms. By the end of this, you should have a general understanding of how the technology works, why we want our Aerospike users to be interested in it, and why Aerospike as a company is interested in it. I'll leave you with a few resources as well. And just to give you a brief overview, this is an engagement that's been going on for several years. I've actually been working with Aerospike since before Intel's hardware has been available. So it's been really nice to see that development from the beginning. We also work with Aerospike. I think somebody mentioned this in an earlier session. We use them often as launch partners because we get really great data from them. So we've used them in the past for our SSDs and our Xeon processors. So my slide says Intel persistent memory, and then based on Intel 3D XPoint technology. And that's kind of the distinction that we want to make today. This 3D XPoint technology came from a collaboration between Intel and Micron. It is a brand new technology. It is non-volatile. I'll kind of explain at a high level how it works. I think Brian did a nice job of giving some of the background of it as well. But at a high level, what you see there are columns of memory cells. There's a memory cell itself and then a selector. The bars on the top and in between and the bottom are wires that connect the memory cells. So for instance, what you would do in order to select a memory cell would be to maybe take the top leftmost wire, select that one, select the wire that's in the front, and the intersection of that is just one single memory cell. So this is in stark contrast to maybe a traditional memory technology where you're selecting an entire row. The way it works to change the data, all you have to do is vary the voltage that's being sent to the selector. There are no transistors on there. With that and the fact that we are stacking it, we are able to offer a higher density than you would traditionally see in your memory today. So that's the underlying technology, but what Intel's done with it is create two different form factors. The first one is on the market today. You can go online and buy it. It is the Intel Optane SSD DC P4800X series. So these, like I said, they're available today. They are essentially SSDs on steroids, if you will, supercharged SSDs. With this underlying technology, you're able to get higher throughput and lower latency. What I'm really here to talk about, and what is more exciting, is the persistent memory modules. When I say memory modules, you should be thinking of DRAM DIMMs. This is the technology that's not out yet. It will be available soon. And it will be supported on the next generation of Intel's Xeon scalable processors, the Cascade Lake generation. So Cascade Lake is our follow-on to Skylake. So taking a look at the memory modules, it looks like the diagram got a little messed up, but these memory modules are DDR4 DRAM DIMM compatible. They will sit in your system right next to your DRAM memory. They're electrically, physically the same. They are expected to be lower cost than DRAM. There's a side note, they're expected based on similar capacities. And the really cool thing is they retain data after a power cycle. So when you think of memory in your DRAM slots, you know that you're losing that. However, with Intel's persistent memory modules, you are not losing it. It's a big shift in perspective and how you think about memory. And what this actually means to software is that we've now added another tier in the memory hierarchy. You still have your caches that are fast and expensive. You still have your main memory, not quite as fast, not quite as expensive. You still have your storage, which, as we know, is slower but less expensive. And what we're adding here is something that's closer to the main memory level in terms of speed and cost, but it's persistent. So that really should make you think about what kind of applications can take advantage of something like this. And it really does require some re-architecting of some software that's been around for a while. The software does have to be modified to take advantage of this, but don't worry, the changes aren't as scary as they sound. At this point, you might be wondering, well, if it kind of acts like an SSD, why don't I treat it like an SSD? And the answer is you can, but we think we actually have a better solution. And that's evident when we look at the characteristics between storage and persistent memory. And just keep in mind, when I'm using the term storage, I'm specifically talking about SSDs, hard disks, magnetic tape, whatever you want. When I talk about persistent memory, I'm talking about Intel's new technology. So for storage, your only choice for I/O is block. I want to write hello world to a file. I'm working with a 4K block, even though I'm really only changing a few bytes. Sure, I could make that write asynchronous, do some useful work on the side while I'm waiting, but I'm still waiting. I'm still going through the file system, the device driver, the kernel's got to get involved. When you compare that to persistent memory, it is byte addressable. If I'm copying, of course, I would do hello pmem. I'm working with as small as a 64-byte cache line. So that really affords you some flexibility and a lot more options. It is synchronous, but your I/O completes much faster. And the big idea is this, that you can load and store your data without involving the kernel. I know that sounds a little bit strange, but we'll look at that on the next slide. That is very unique. That is very exciting as a software developer to have that power. And those of you who know that what's involved in switching to the kernel know that that's a big implication for performance. So Intel's been working with a group called SNIA, or the Storage Networking Industry Association. They are a global nonprofit organization with members like Microsoft, Dell, Samsung, Oracle, I believe, and they come up with these standards. So this is not an Intel-driven programming model, and you'll notice that nowhere on that model does it say Intel, but Intel's contributing to it, and our devices follow this model. Theoretically, anyone who has a persistent memory device could follow this model. It's meant to be industry-wide and non-agnostic, or agnostic, excuse me. So what I'm showing you here is how the application interacts with the persistent memory device. And there's a couple ways to do it, but what's really most interesting is this area highlighted on the right side of the slide. And this is the case that we've worked on with Aerospike. So you do have a persistent memory-aware file system that's doing some management behind the scenes to access the device. But when you have a file that you open on your persistent memory device, all you have to do is map it into your map the persistent memory to the application address space. If you're familiar with mmap, it's very similar to that. What this does is completely bypass the file system, the device driver, the kernel. Your data is not buffering in DRAM. You're getting it directly from your persistent memory device. And in actuality, your application has direct access to that persistent memory. So we think that this is really takes the most advantage of what persistent memory has to offer. Which brings us to Aerospike. I was going to draw this out and have you kind of guess what it is, but I think the cat's out of the bag at this point. For Aerospike, the use case that we started with is to move the primary index out of DRAM and put it into this persistent memory. Now, the first thing that you should be thinking of if you're an Aerospike user, if it's persistent, does this mean I don't have to rebuild my index when I reboot? And the answer is yes, which is really cool. We all know that systems go down, they need maintenance. Rebooting is part of life. If we can speed up that time to get back up and running, we think that it's a really, really valuable thing for you to have. So what happens on a reboot, your data is still on SSD, your index is on persistent memory. Really, all you have to do is reattach. It's as simple as updating some pointers, a few other things. But you're up and running much, much, much faster than you would if you had to rebuild the index. We are able to offer higher capacities. I'm not able to give specifics on that, but you will be able to have high capacity DIMMs. There's some options there. If you want to store more data and you have room on your SSD but not in your memory, here's another option. Instead of buying another system, you can install some of this persistent memory and be able to index that extra data. Again, if you're not using DRAM for the index, maybe that frees up DRAM for something else, a secondary index, or maybe you just don't buy as much DRAM, which we all know is a huge cost for IT. I've already touted the warm start after power cycle with double exclamation points because it deserves that. And the last point is that we really maintain throughput. I can't say that the performance is exactly equal. The persistent memory media is slightly slower than DRAM, but we've done some work with Aerospike to make sure that there's very, very little impact to performance. So like I mentioned earlier, we've been working with Aerospike since before this hardware was even available. We did some prototyping to help them understand what they could see as far as the performance impact. And then I've been working with Andy closely over the last, year, maybe even longer, to actually implement the changes in the software, do some testing, some optimization. But from an Intel point of view, Aerospike's been one of our early partners to reach out to us and to work with us, and we think that that puts them and us on a better playing field for all of our customers. So, in case I haven't hammered the Intel marketing terms enough, this is what you should remember when you think of persistent memory. Obviously, big, persistent, affordable, and robust. We all know that TCO is really important if you're running thousands of nodes, whatever. If you're able to save money on your memory, possibly scale out less, that could make a big impact. We all know Aerospike already helps you reduce TCO. This is just an addition to that. And then that system downtime, that annoying wait time that we all hate, we're reducing that with you, with persistent memory. I'll leave you with a few resources that would be of use. Intel Developer Zone has a lot of great video tutorials, blogs, documentation that you can check out. They have a specific section just for persistent memory. The Persistent Memory Development Kit is actually the Intel, not Intel based, but Intel participates in developing these libraries for persistent memory. You can take a look at the different libraries available. You can do quite a number of things with this development kit. And then earlier I mentioned the Storage Networking Industry Association. There's a lot of great material there as well. So in conclusion, look for really great things from Intel and Aerospike together in the future. And thank you very much for having me.